So this is how you assemble your mobile. Make sure that it's balanced. You have measured the masses here for your 4 objects. You have measured the masses of the rods. And now you're going to measure the distances on here, and then you're going to make the calculations. So I'm just going to do one example over here. So there's a buffalo here, and now I need to get the meter stick, which only takes a second. And I'm going to measure here 23.7 centimeters to the left of the string, so that's going to be a negative 23.7, and the mass of the buffalo, I measured that earlier as 131 grams. The musk ox here on the right, I'm going to measure to 15.7 centimeters, and that's to the right, so it's positive. And then the musk ox has a mass of 198 grams. And then I have to pay attention where the middle of the rod is. Here's the middle of the rod, and so I have to measure here to the left, because the buffalo is on the left as well. So this one is going to be a negative as well. So that 4.8 centimeters is actually a negative 4.8 centimeters. So again, you measure, you decide which object is going to be on the left, and you stick with it. So the buffalo will come out with a negative distance. The musk ox will come out with a positive distance, and because the middle of the rod is to the left, that also comes up with a negative distance. And the reasoning is that this pulls to the left, this pulls to the right, and the middle of the rod here also pulls to the left. So again, this is negative. Then you do your drawing here. And this here would be the left part, and the person who drew this here apparently was very accurate on the drawing. Notice though that they made a slight scale mistake here. That string should be over here. So here we have a larger distance, and here we have a smaller distance. But I forgive them that for the nice drawing that they did. Then you plug in the numbers, and I have this in another recording too, where I show you how to do the calculations. You plug in the numbers. As I said, in this case there are a couple of negatives in there. You do the calculations. You come up with, or they came up with, 0.05 centimeters, which is right on. It can't be any better than that, which means their center of gravity is half a millimeter off from the pivot point, virtually zero. So this is for assembling the mobile, and you're going to take a total of 3 rods, and you hang them up with strings. And here come the strings. There we go. Hope this is not gonna take me too long here. Okay. And with these here, I just mark where the pivot points are, which is going to be also the 0 markers. So whatever you're going to calculate later on has to come out to that 0 where the pivot markers are. Okay, now I'm going to put the objects on here. Of course, whatever objects you're using. Okay. And the car. And there we go. Okay, now you have to see what you have to measure. Of course, you have to measure the masses. So the mass of the teddy bear here, M1, the mass of the toy car, M2, mass of the toilet roll, M4, the mass of the umbrella, M5, the distances at which they are. So here for the teddy bear, and I put this in kind of this bluish color here, meaning that you have to measure as you're measuring to the left, you have to keep it negative. So this one has to be a negative distance, always measuring from the pivot point to where the object is suspended. And so for the toilet roll here, this would be the same deal. There. And then for the car, well, it would be a positive distance, and for the umbrella, that would be a positive distance. There we go. And then, of course, you label these as x1, x2, x4, x5. Then you're not done yet, because the rods themselves have some mass, so you have to figure out where exactly is the middle of the rod, because that's where it pulls. In this case, the middle of the rod is to the right of the pivot point, so I'm gonna measure here to the right. So actually this one here is really tiny. This one here I would call then x3, and then the mass of the rod I would call m3, and this was supposed to be a 3. Over here the mass of the rod would be m6, and then here apparently I have to measure a distance x6, and I have to mark the middle of the rod. I want to say approximately here. This again is also measured to the left, so it comes out to be a negative. And you have to pay attention to that. Okay, so far so good. Okay, actually the part of the mobile on the left is done, the part of the mobile on the right is done, so you could already make a couple of calculations, and then you have to do the entire mobile, and for that you would have to say that, well, I have a total mass here, and I have a total mass here, and this one here I call MA, this one here I call MB, and the two are a distance of XB from the pivot point and XA from the pivot point, and those distances are here, and of course XA again is measured as a negative, and XB is measured as a positive, always from the pivot point, always towards where the weight is, where the mass is suspended, so to the string there. You always measure just the horizontal distances, you never measure the string lengths, they're inconsequential. And then for this top bar here, I also need where the center of mass is. It's approximately here, so in this case again I come up with a positive length. That's how you set up your mobile. That's how you're measuring. And let's see, I think I have to label this one here. One more label. XC is this distance here, and then the mass of the rod is called MC. And when you look at the drawing that is supplied on the lab sheet, then you will see that I pretty much reproduced that drawing. And as I said, this is how your mobile should look at. Measure everything that you're supposed to measure. Don't take it down, because if you make a measurement error, if you come up with a result that's wrong, you may have to measure again. And this one is a very accurate experiment, so you should come up with very good results. So as I said, keep it up and make sure that you measure correctly. This recording is for showing how to measure and then what to do with the numbers. So let's say we were to measure, for example here, 78 grams for the teddy bear and 31 grams for this toy car and 8 grams, 8.0 grams for the rod. And let's say that the rod is to the right hand side by 2.5 centimeters and the toy car suspended to the right hand side by 10.8 centimeters from its suspension, which is the string, to the pivot, which is the string that holds the rod. And then the teddy bear is to the left by negative 4.6 centimeters. Remember, when you measure to the left, you have to measure negative numbers. Okay. And this is, of course, an example. I just completely make up the numbers. Well, just for an example here, so I made them up out of the blue. So let's go over and see what we're going to do with the numbers. Okay, so here I'm going to put in M1, that was 78 grams, and then M2 I put in as 31 grams, and M3 as 8.0 grams, and X1 that was a negative 4.6 centimeters. Notice I supplied the negative already here because we know that one of the two numbers, the one that's on the left, has to be negative anyway. And then I have a positive 10.8 centimeters here. And then for the rod itself, well, here I don't know if the middle of the rod is to the left or the right. That's why I didn't write the negative or a plus here. You would have to do that. So in this case, it was a plus 2.5 centimeters. If I remember the other, the drawing on the right hand side, that X6 I believe it was, would be actually ending up with a negative in front. Okay, so here this is how you plug in the numbers. Okay, and then they go in here. It's M1, which is 78 grams, times negative 4.6 centimeters. I'm going to leave out the units. We know this is gram times centimeters in the numerator and grams in the denominator, which means that the grams will cancel and we just have centimeters left at the end. Okay, so 78 times negative 4.6, and then we have 31 times 10.8, and then we have 8.0 times 2.5, and in the denominator we have the total mass here, so 78 plus 31 plus 8.0. And we're going to do the calculation in just a moment, but what we would expect here is, what we have to expect is that the center of gravity comes out to be 0 because it has to coincide with where the pivot is, and since we defined our pivot as the 0 point, our result has to come up with 0 respectively, since it's a measurement very close to 0. So let's go over to a calculator and calculate it there. Okay. This can be done, one thing at a time, 78 times negative 4.6 and so on. I like to do it all at once because then I can easily go back and fix something that I had that went wrong without having to go through 4 steps or so, but just fix one thing and do one big step here. So 31 times 10.8 and so on. And I meant to hit the decimal point. I missed it. I'm going to leave it the way it is right now. And by that we will expect that I will have a mistake here, and we'll see what happens. So 78 plus 31 plus 8.0. Make sure that you put parentheses around denominator and numerator. hit enter. I should come up with 0. Obviously I don't, which means I have some mistake there. In fact, my result is so bad I must have made a huge mistake. And I said that earlier, that was accidentally. I left out that period, and here's why it comes in convenient. When you type in everything at once, I just go right there where I notice that's where I left out the period, the decimal point. Hit enter. And I come up with negative 0.034 centimeters. I could call this negative 0.034 or negative 0.03 centimeters. So that would be my result right here. 0.034 centimeters. I wouldn't have to make this any more accurate. In fact, I could almost truncate here. I could almost make the point of, I could almost truncate it right there. I'll leave the 3.4 there. I could almost write 0.0 centimeters because I didn't measure any more accurately than a tenth of a centimeter. In fact, the other numbers are rounded to the closest centimeter. So the negative really here doesn't mean anything in the front of this. This just means that my calculated center of gravity is to the left of the pivot point. If it was a positive, then it would be to the right. It's supposed to coincide with the pivot point anyway, and overall that means that I'm really close to the pivot point with my center of gravity, and that was the idea, to calculate the center of gravity, the torques which are acting on the objects as they're pulling down on different parts of the mobile, and calculating center of gravity.